Section 6.1, our objective is I can apply properties of inequality. So first of all, let's go over the properties of inequality. You saw these in algebra, but let's go over them. So the first one says, in algebra you saw, if x is greater than 7, then x plus 2 is greater than 7 plus 2. Okay, so in other words, in an inequality, if you add the same amount to both sides, then the inequality stays the same. In geometry, we would use it something like this. If length of AB is less than length of CD, then length of AB plus 2 is less than length of, CD plus 2. Okay? So if you add the same amount to two segments, and the original one is shorter than the second one, then the inequality still stays true. The next one is if x is less than 7, then x divided by 2 is less than 7 divided by 2. Okay? And it's also true that if you multiply both sides by 2, you get 2x is less than 14, which will still be true. Okay? In geometry, the way that we would use this would be something like this. If measure of angle A is greater than 60, then 1/2 measure angle A is greater than 30, or 1/2 of 60. And 2 times measure of angle A is going to be greater than 2 times 60, or 120. Okay? Right. The third property of inequality is if x is greater than y and y is greater than 7, then x is greater than 7. So this is kind of similar to the transitive property, only we just don't call it the transitive property, it's just a property of inequality. And the way that we would use this in geometry would be something like this. If AB is less than, or length of AB is less than length of CD, and length of CD is less than length of EF, then length of AB must be less than length of EF. Okay? So again, very, very similar to the transitive property, but we just call it a property of inequality. And then, then the last one is if x is equal to y plus 2, and x is greater than y, if x is equal to y plus 2, then x is greater than y, and x is greater than 2. This property, we often say the whole is greater than its part, okay? Because y and 2 are both part of x. They went into making x. So x has to be bigger than either of the two, okay? And we have if measure of angle A is equal to measure of angle 1 plus measure of angle 2, then measure of angle A has to be greater than measure of angle 1, and measure of angle A has to be greater than measure of angle 2. Okay? So these are the main properties that we'll use, but remember also from algebra that if x is less than 2 and you multiply or divide by a negative, in other words, let's say that c is less than 0 is another way that we multiply or divide by 0. Then x times c is greater than c times 2. And x divided by c is greater than 2 divided by c. Okay? So remember that when you multiply or divide an inequality by a negative number, you have to flip the inequality. Okay, so let's look at some examples. So, are these true or false? Number 1, if 3x plus 2 equals 8, then 8 is greater than 3x. Okay, this is true because the whole is greater than either of its parts, and 3x plus 2 equaled 8, so 8 is the whole. Okay, number 2, if A is less than B and C is less than B, then A is less than C. Okay, this one is false. Okay, to be true, it would have to be A less than B and B less than C. Then it would be true. Okay, but the way it's written, it is not true. Number 4, if 4y is less than 16, then y has to be less than 4. That's true because we divided both sides by the same number. Number 4, if C is less than D, then C minus 9 is greater than D minus 9. Okay, this is false. In order to be true, if you subtract the same amount from both sides, the inequality doesn't change. So in order for it to be true, it would have to say C minus 9 is less than D minus 9. Okay? So again, if you are going to use one of these properties in a proof, the statement that we use is just a property of inequality. Okay? So if you use the property in a proof, the reason is a property of inequality. Because each one of the properties doesn't have a specific name, so we just say a property of inequality. All right, and then we have a very important theorem. It's called the exterior angle inequality theorem. Okay, So when theorems have a name, it's usually because they're really important and they're used a lot, okay? And the exterior angle inequality theorem says the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Okay, so let's look at this. Okay, so what it's saying is we have some triangle A, B, C, and we have exterior angle X. Well, remember that this exterior angle is equal to the sum of the two remote interior angles, which would be this angle, we'll call it angle 1, and this angle, we'll call it angle 2. So we know that measure of angle 1 plus measure of angle 2 has to equal measure of angle X. Okay? So the exterior angle inequality theorem is just a restatement of the fact that the whole is greater than either of its parts. So what this theorem says, it says measure of angle X has to be greater than measure of angle 1, and measure of angle X has to be greater than measure of angle 2. Okay, so it's just a restatement, basically, of that property. All right, so let's look at this triangle. This is W, X, Y, and this is angle 1. This is point Z. Okay, and our given is we have triangle WXY with exterior angle 1, and we know that WX, length of WX equals length of YW, or WY. Okay, so we know that this is congruent to this. And we know that Z is the midpoint of XW. Okay, so tell whether the following statements are true or false. So number A, measure of angle X has to equal measure of angle X, Y, W. Okay, yes, that would be true, and that's true by the isosceles triangle theorem, because angle X and angle XYW would be the base angles. Okay, B, is it true that measure of angle 1 is greater than measure of angle W? Yes, that is true, because angle W is a remote interior angle, and so we know that the whole is greater than either of its parts. So this is true by the exterior angle inequality theorem. Okay? All right, C. Is measure of angle W less than measure of angle X? Okay. We don't know, because there's not enough information about angle X and angle W. Because this could be an equilateral triangle. So W could be equal to X, okay? Or W could be greater than X, so we don't know. So this is a question mark. We can't say that for sure. And let's do one more, D. Okay, is it true that length of xw is greater than x of zw? And that would be true. That's yes. And we know that because of a property of inequality, which is the whole is greater than either of its parts. So this is a property of inequality. Okay? All right, let's do one more example. Let's look at this line segment. This is A, B, and C. And we have line segment D, E, and F. And we are given that B is the midpoint of AC, and E is the midpoint of DF. Okay? And we're also told that length of DF is greater than length of AC. Okay? So DF is a longer segment than AC. So what we want to say is this statement true from what is given, or can we not tell from the given? Okay, so is there no conclusion? So number A, can we conclude that length of DF is greater than length of DE? Yes, we can conclude that because of a property of inequality that says that the whole is greater than either of its parts. So yes, we can conclude that that's a true statement. Is the statement that length of AB plus length of BC equals length of AC, is that a true statement? Yes. By the segment addition postulate, that has to be true. C, can we determine that length of AB is less than length of BC? Okay. And this would be a no. Okay, that is not a true statement. Okay. D, can we determine that DE is greater than AC? No, we don't know that. There's no property or postulate or theorem that we can apply there. E, can we determine that EF is equal to 1/2 of DF? And yes, we can determine that by the midpoint theorem. Okay? And can we determine that DE, length of DE is greater than length of AB? Yes, we can determine that because we know that DF is longer than AC, and so then half of AC would have to be less than half of DF. Okay? All right.